I'm working on the perfect home server, and I keep sort of vaguely stumbling toward something like 2 groups of 3 5¼ inch drive bays. And after my last video, a ton of you suggested the N1 was really what I needed. It was, something a little interesting, so I decided to see what I could build in this with AM5. And I ended up not being able to resist the temptation to visit the bandsaw. Wait, what? Ah, use this as a build guide, or cautionary tale. This video is brought to you by EnGenius, which is what I use at home for my wireless, which is a very difficult situation. I love it, couldn't be happier. I've tested both the cloud managed and the on-premise managed EnGenius hardware, which is different, except for now we've got a newcomer to the EnGenius family, the EnGenius FIT line of devices. Here I've got the FIT 6 4x4 Wi-Fi 6 dual band indoor access point, EWS357-FIT. You should definitely check this one out. You should check out my full review, but this access point, 2.5 gigabit power over Ethernet, 2.5 gigabit Wi-Fi 6E. You can do 1.1 gigabit in the 2.4 gigahertz band, and let me tell you, this access point excels with a lot of old, crappy 2.4 gigahertz devices. Setting these up could not be easier, even for a mesh, and you don't have to decide how many devices you need in the mesh right now. You just take it out of the box, you take a picture of a QR code, and you're good to go. If you don't want to use your mobile phone, there is a web management portal. You can use that instead, or you can do total on-premise management, although at the time that I'm making this ad, that's not quite done yet, but that is one of the advertised features of the EnGenius FIT, is being able to manage it on premise. The underlying hardware that EnGenius has sort of co-opted for their product is extremely well built, and that's what drew me to EnGenius in the first place. So check out that ad, check out the new EnGenius FIT line. It may be more of a fit for what you're looking for. It doesn't have all of the features of the higher end access points, but they're also less expensive, but you still get that 4x4 antenna hardware. It's really just a software change. All right, on with the video. So for this build, should be obvious, we're going to use a lot of M.2 cheat codes. That's literally the name of the video, M.2 cheat codes, I think. And that's where you use a bunch of M.2 connectivity in order to do something a little bit unholy. Jonsbo N1, you can use it in this configuration. It comes with feet. You can use it horizontally. I reviewed this motherboard separately, the B650i Aorus Ultra, and I talked a little bit about this build there. This has 3 M.2. There are a couple of AM5 motherboards that actually have 4 M.2, but this one with its 3 M.2 gives us a lot of functionality, but also it gives us 4 SATA ports. This case has 5 3.5 inch mechanical drive bays, plus room to add another 2.5 inch drive, be they SATA, or even be they U.2 Optane. You can add Optane to the N1? Yes, you totally can. Even a PCIe 4 speeds with the right M.2 cheat code. With the right M.2 cheat code, we can even add more slots. We could turn the X16 slot into 4x4 slots, although fitting them all in here would be tricky. This, with the PCIe redrivers, is what you need in order to drive a Gen 4 drive. That could be Optane, it could be anything, in the U.2 form factor, the 3.5 inch U.2. Even there's a U.3 version of this as well. This is the Gen Z connector, so this can technically do PCIe 5 speeds, though most of the redrivers and stuff that you get from AliExpress or eBay, it's just Gen 4 rated. I'm getting ahead of myself. Let's unpack. If you didn't see our other video on M.2 cheat codes, you should definitely check that out. As I was saying, storage, networking, whatever you need, you can do with M.2. This M.2 is also a little misleading. It's like, I'm gonna have 6 full performance SATA ports. No. If you're running SATA SSDs through this, the best you can hope for through this card is about 2.5, 3 gigabytes per second. It can't even really do the full 4 gigabytes per second of a PCI Express 3.0 interface. And it does get a little toasty, needs some good airflow. It will throttle when it gets hot. But for running 4 drives off of the motherboard, plus another mechanical drive off of this card, and maybe like 2 more SATA SSDs, this will be fine. Just prefer the motherboard SATA, usually, versus this kind of unholiness. Alright, so for this build, I've got our SFF power supply and our AM5 motherboard, and there's kind of a lot crammed in here. It's a little bit of a messy build. I've sort of left this not in an ideal state to just show you and give you an idea for this video. Now, if you're gonna do this, you'll understand the internal layout of this case. I like the tower layout a lot better than I do the desktop layout, but it's a little more dangerous if you have, pets. You probably do want to just use this horizontally. It's a lower center of gravity. If this turns over like that while it's on, it's going to ruin your hard drives. You're going to lose whatever mechanical storage that you've got here. This case comes with a hot swap bay, so you can sort of pull the drive in and out. The original legendary case for this kind of a build was the Fractal Node 304. And yeah, I know Fractal's got a micro ATX version-ish of that case, but too little too late in a lot of ways. But the Node 304 is legendary. It doesn't come with the hot swap capabilities, and it will hold 6 3.5-inch drives grouped in sets of 2 drives, which I think was kind of a weakness of the design of that case. But it would hold a 2-slot GPU, and Fractal did a good job, blah blah blah. This is a better choice for server build that's ITX for a lot of reasons, and I can say that now because I've built in it. But it comes with, it's a little problematic because I've got too much stuff crammed in here, and so as I pull the drive out, it gets a little caught up on the wires. But you're not pulling the drives in and taking them out constantly. It's just got little rubber grommets that you use for mounting the drives, and if you don't overly tighten it, you really don't have to pull on it very hard. So the rubber thing, it works pretty good in terms of sound dampening, works pretty good for the problem that it's trying to solve, and you get some bays in here in the front that are hot swap. You will probably want to reverse the fan in the top. By default, it's sucking air in from the front and blowing it out the back. I get why they did that. In a tower configuration, I've got it flipped so it's pulling air. If you're going to use this in a horizontal configuration, you don't need to do that. I also modified this case a couple of different ways because the expansion card that I wanted to use was not physically fit. Synology comes to our rescue here. This is the E10 M20T1. This is a PCIe card that doesn't require bifurcation support or anything like that in your BIOS, but will give you a 10 gig Aquantia Ethernet interface and 2 110mm M.2. 110mm, assuming you don't have to get to the bandsaw, which I'll get to that in a second. This is a great card. This is fabulous. It's meant for Synology NASs. Sometimes you can pick these up on eBay. There is a price premium because you're cramming this in here. I don't actually recommend that anybody do this. I just want to show that I did it, and it can be done, but I don't recommend it. And what I had to do was trim the end of the card because it wouldn't physically fit. And even if I could trim the mechanical stuff here, it meant that it would block some of the SATA connections on the back plane. So I really want my SATA connections. The case could be a few millimeters taller. Okay, this makes sense because I want 10 gigabit. With 10 gigabit, I was able to copy information to our 20 terabyte array. If it's 5 drives big, I can easily copy at about 700-800 megabytes per second. At 3 drives big, this is the current configuration. I'm using 3 drives, 1 for redundancy, 2 for storage. This gives me about 40 terabytes of usable capacity because 20 terabytes is for redundancy information. I'm running TrueNAS on this. We'll talk more about the software stack in a minute. This is mainly not a software stack video. Now, with the aforementioned selection of cheat codes, I opted to use one of our M.2 slots for a SATA controller. This has 6 SATA ports. This lets me fully populate all 5 connections for mechanical drives, but it also lets me run some additional SATA drives down here that are SSDs, 2.5-inch to be precise. So I can have the operating system part of the drive. These are just little cheap inland from Micro Center SSDs that are running my operating system, but I can cram 2 of those in here. I could probably get more than 2, but 2's pretty easy to cram in our N1 and still have room for this. It is kind of annoying that all of the cables are sticking out of the sides, and you have to use right angle SATA cables. And really for this motherboard setup, you're going to need some double right angle SATA cables because of the way that the SATA connections come off of the motherboard. If you didn't check out the motherboard review, be sure to check that out because there's a riser card that gives you your front panel audio connections, your PCIe 5 M.2, there's an M.2 on the back of the motherboard, and then you've also got a connection for your SATA. And that header has 4 SATA connections on it, 2 that come off in the front and 2 that come off the top. So the ones that come off the front, you need some right angle SATA connections. So that's what I had to do here. If you're gonna special order SATA cables, you might as well get the thin foil kind. These are really, really easy to bend. They're easy to tuck in anywhere, but these are also really easily damaged. A lot of the consumer grade SSD cables, it's this kind of cable in the wire, but there's a really thick plastic coating on it to sort of protect it. So just, if you get some of these are server grade SATA cables. If you get some of those, just be careful with it. And yeah, it is worth the extra effort to order shorter SATA cables so that you're not dealing with a mess like that inside the case. Because taking the case on and putting it off, a little bit of a headache when all the cables are trying to escape constantly, be they SATA or other connection cables or even your power supply cables that are stuffed in here. Now we're using an EVGA 450 watt SFX power supply, and that worked out fabulously. This thing only draws like 280 watts at peak, and that's with running an artificial GPU transcode. That's on the Linux side. It's not something that TrueNAS does properly with Jellyfin or Plex or anything with these AM5 Ryzen processors, but that's coming soon, I hope. Long story short, the maximum power draw from this thing is well under 450 watts. The nominal power draw is 60 to 70 watts, even with mechanical hard drives in here. If you're willing to get your hands dirty with a newer Linux kernel, you can actually push that down even a little bit more. Although at that point, when you're really doing that kind of stuff at a system level, TrueNAS scale may not be the operating system that you want to use to get that level of power saving. I also was able to fit 4 Optane in here, usable for a striped mirrored metadata special device. If you're not clued into using ZFS, you should get clued into using ZFS. It's awesome. But one of the features of ZFS that's optional is being able to use SSDs, in our case Optane SSDs, which are really awesome for wear leveling. They shouldn't wear out in it for a very long time. 4 of them packed in here. 2 of them on our 10 gigabit card and 2 of them on the motherboard. So all of our M.2 slots are used here. We've got 4 that are occupied by Optane, and the 5th one has got our SATA controller in it. There's no free M.2 left on this platform. But with that, I'm able to use all of our indexes and everything from SSDs. So all of our file storage is on mechanical storage, and all of our where is that file allocation table stuff basically lives on our Optane SSDs. And that works out really well for a media server, transcode server, whatever you want to call it. You could use non-Optane SSDs for caching, but I wouldn't recommend it because flash drives wear out, and that's some of the busiest area of your storage medium. If you do it, at least use professional grade or server grade, something like the Samsung 980 Pro, and hopefully you're not really changing the data on your array all that much. You can get away with it. There are people that are definitely just using regular old NAND flash devices to do it. It does work. Just keep an eye on that, and maybe run with some extra redundancy. You could do a 3-way mirror instead of the 2-way mirror that I have here, but 3-way mirror would probably be a better choice if you're going to use something a little less reliable than enterprise grade Optane. Of course, enterprise grade Optane's on fire sale right now, so it's an option. Now you might be wondering, why did I choose AM5? Why did I choose the 7900? And is this cooler sufficient? It's like, well, this is a little misleading. That's actually not the cooler that ships with the 7900. The cooler that ships with the 7900 will not fit in the Jonsbo case. If you get the 7600, that'll fit in here fine, but that's also not the cooler from the 7600. This is the cooler that we're using with our 7900 that's in here, and it just barely is enough to keep up. These are the non-X versions of these CPUs. It's got a copper slug in the middle. This thing does a pretty good job cooling it. I would like to use an aftermarket cooler, but that introduces a lot of problems. One, our B650i Aorus Ultra, the rear I/O shield is kind of tall, so our CPU cooler doesn't really fit super good with that. We also don't have a lot of clearance here for our CPU cooler. Be sure to check the N1 manual to make sure that the CPU the cooler that you plan to use will fit according to the manual. I get the Scythe. I love Scythe for their creative coolers, and this is a low profile downdraft cooler. It's normally meant to, you can rotate it, and it's normally meant to run over the rear I/O or the VRM, but it's not going to work on an AM5. You can turn it this way, and this will clear the memory. It will only work with the JEDEC reference DDR5, which is DDR5 memory that's this tall. So if you've got RGB or something like that on your DDR5, it's not going to work. The other thing with this build is, does it support ECC? At first, it did. the B650i Aorus Ultra with the F2 BIOS will post with error-correcting DDR5 memory. That's what this is. If you look closely, there's an extra chip on both sides of this DIMM. That's because DDR5 is technically dual channel. It's dual channel, but each channel is half the width of DDR4, so the number of bits per DIMM is the same, even though this DIMM is technically 2 memory channels. So it's faster and fun times. Yeah, DDR5 is different. Just know that DDR5 is different. And also know that non-error correcting DDR5 still has error correction built in, but it's error correction and detection for when data is in transmission. This type of error correction in DDR5 is for data at rest, which is why physically there's 2 extra memory chips, as well as data in transmission. So if something is written to memory and then sometime later read back, this makes sure what was read and written was the same. That's something you get just for free with DDR5, as well as while it was stored in the chip, that nothing changed. It can detect
2-bit errors and fix 1-bit errors
across a across a word boundary, I guess is what we're talking about. But normal DDR5 can't detect errors that happen while it's stored, just in transmission. Unfortunately, with the latest 1005 or newer AGIZA on this board, the newer board, so it's F4B or newer BIOS, this motherboard no longer supports or will post with error-correcting DDR5. Very unfortunate. Something I hope Gigabyte fixes. And if they do, look for a pinned comment below, because this is one of the motherboards that I'm going to use to monitor the error-correcting DDR5 situation. So keep that in mind. This cooler would work if you use low-profile memory on this motherboard, and it would work really well. You've got just a tiny little bit of extra room in this case, but the most practical solution is good old copper slug reference cooler. And you can get these on eBay for about 20 bucks. Cooler Master has a version of this as well. You can check that out. Use that with this build. That works fine. Now, is it a showstopper that you're limited to the 2.5 gigabit that's built into this motherboard? After using this as a media server and book server, so I store all of my books with annotations and media and run a bunch of Docker containers and Pi-hole and a whole bunch of stuff on this, I don't think the 2.5 gigabit thing is a real limitation. It's 250 megabytes per second, which is about the same physical speed as you get from one mechanical hard drive. Most people are not going to run an SSD home network storage server, and if you do, it's going to be in something more elaborate than this. This is small enough and quiet enough, even in this configuration, that it would make sense in a living room. Speaking of noise, this fan is plugged directly into this backplane for the drives, and this fan runs at 100% all the time. It's audible. It's pretty loud. You've got some extra 4-pin connectors on this motherboard that come off of a header. This ITX motherboard actually has 3 usable 4-pin fan headers. And so you can plug this fan not into the drive backplane, but into the ITX motherboard fan header and set up fan control, a customized fan profile. At that point, the Jonsbo 140mm fan in the top here is completely reasonable for this build. This is the enthusiast every person home server build that you want to do something fancy with the software, something really high end, have a lot of fun with it, and go AM5. Do you need to go AM5? Do you need something this high end? No, you could do this with a Raspberry Pi. You really don't need a lot. Sometimes people just need storage. Sometimes people need media transcoding. What this doesn't do and doesn't give you an avenue for is GPU transcoding. It's unfortunate, but it's true. It won't physically fit to have a GPU in here, and that is the easy button solution. Of course, that's also going to use idle power, and it's not great. The transcoder, fortunately, that's built into AM5, actually very good. So this has an iGPU. You don't need a GPU in here to hook up the console and see everything. You don't need the GPU to do transcoding. It's just the software support for that, and Plex and Jellyfin and everything else is not there yet. But if this gets into enough hands, I don't think that's really going to be an issue. If you like this look and this form factor, but 2 physical mechanical hard drives would be enough for you, you might also check out the reserver from Seed Studio. We did a video on that. It looks aesthetically almost identical to this, and it's physically smaller. It's just a 4-core system. It uses notebook memory, has 2 physical 3.5-inch slots. It has 2 M.2 slots. You can still do the Optane for your metadata special device with redundancy. It's a really fabulous platform to build stuff on. It's also very low power, and very flexible, very customizable. It's got 3D printable accessories. There's a huge fan base around Seed Studios thing for your home server. And it also has two 2.5 gig NICs built in. So it's got better connectivity than this thing does out of the box. Not better with my hacked up 10 gig bandsaw upgrade. Quantia Ethernet connected. But, you know, pretty good. I've got 2.5 and 10 gig now with this platform. Yeah. Now, while the 7900 is something special with its 12 cores, that is a monster CPU for a home server. Unless you're a software developer or somebody that's going to go nuts with software, you don't need it. The 7600, no X, is perfect for this platform. 6 cores, 12 threads. It is still a single thread performance monster. And that will even run circles around a 16-core socket 2011 Xeon, like a 2650, an E3 2650, just barely edges out the 6-core when we're talking about multi-core performance. But for transcoding with the hardware assist, plus CPU-bound tasks, plus everything else, that dual socket 2011, this thing's got nothing on it. You want to run 64 gigabytes of memory on this platform? That's surprisingly affordable. I actually ended up using T-Force memory in this that is slower than DDR5 6000 because it was on sale, because everybody wants to get rid of their kits that can't do DDR5 6000. And so even though this is 32 gigabytes of memory, it was basically free with other stuff that I was buying at Micro Center, which is just, okay, sounds good. And yet, for this use case, performance doesn't really suffer. So in summary, even if you're kind of a hardcore enthusiast, this ticks a lot of boxes. You can rock 100 terabytes plus in here. It's plus when we've got drives that are physically larger than 20 terabytes. You can sort of start out with 40 terabytes as I have here and grow over time. You can have more redundancy if you want. You can have SSD caching if you want. You can have a 10 gig Ethernet interface if you want. You can really do a lot with this form factor. It's pretty cool. The Jonsbo N2 just came out. That might be a better choice than this case, because it's an improvement, it's a newer case. Check out the N2 over the N1, but the N1 is also on sale. So at the time that I'm doing this video, it costs less than the Fractal Node 304, which was the reigning champion for like 10 years. So this might be a 10-year case, or the N2 or Jonsbo working on this home server thing could be an option. Unless I could take over the universe with the 6 5.25 inch bay thing that can then sort of polymorph into whatever we need because it's got 5.25 inch bays. I'm just not giving up on the 5.25 inch bay option for home server. That'll give me the best of both worlds with SSDs and everything else with all of the flexibility, because, hey, if you're going to run a rack server, don't run an old rack server. You can run 256 cores with the H242. 4 nodes in here. That's how we get our redundancy. We just throw computers at it. It's like they can't all die at the same time, right? Right? Now, as we march on for our home server stuff, the software stack starts to look more and more and more generic. It's just how you run it. TrueNAS is the underlying part, and it's important because it gives us ZFS and some other stuff. But really, up here, applications, think about like the stuff that you want to run. Stuff like Nextcloud and Ubiquity or Koba or some of the other stuff for your ebooks for hosting. Maybe you're going to run the Caliber book server. Maybe you're going to run other books. You want to host your EPUBs and PDFs with annotations and everything else, plus also audiobooks. Maybe you're going to use the Bookshelf plugin for Jellyfin. Maybe you want to use Jellyfin for your media server. Maybe you want to use Plex Media Server, although I'd really recommend Jellyfin at this point. So I think we need to do a software tour of what is currently my perfect setup, which is Jellyfin and Bookshelf and some other plugins, plus Nextcloud, and how I've got that set up, because you can containerize it, you can run it natively, you can run it in a virtual machine. How do you do it? How do you make it portable? And the secret to that really is your file system. Not ZFS, but how it's organized on the file system, renaming the directories and everything else like that. And for that, I've got to introduce you to FileBot. Is there something better than FileBot? I don't know, we got to go on that journey together, but not in this video. On Windows Level 1, this has been a look at the Jonsbo N1 and where I ended up for the most over-the-top build that you can do right now in the beginning of 2023 for 5 drives, 100 terabytes of storage, 32, 64 gigabytes of RAM, whatever you want to run, 96 gigabytes of RAM with the new DIMMs that are coming out, plus also using our M.2 cheat codes. If you have any questions or you want to see a variation on this, or you want me to try something or do some benchmarks or whatever, let me know. I'm hanging out in the forums. Forum.level1text.com. Okay, I'm signing out and I'll see you there. Yeah, with 3 mechanical hard drives, 500 megabytes per second. Not really much of a problem over the wire. Almost 500 megabytes per second on our SMB share with like 6% CPU utilization. Yeah, it's pretty good. All right, I'm signing out and I gotta go now. I've finally come full circle to the original Apple tech support meme. One of the recordings was, "You saw it off the back of the motherboard?" And it was like, yes.